Welcome to Azure UDR. Please consider subscribing to the channel. I produce videos covering AWS, Azure, and GCP. Hit the notification bell to get notified. Welcome to our comprehensive guide on Azure User-Defined Routes. I'm excited to walk you through one of Azure's most powerful networking features. UDR is essentially your way of telling Azure, "Hey, I don't want to use your default routing. I want traffic to go exactly where I tell it to go." Think of it like being a traffic director for your virtual network. Today we'll explore why UDR matters, when you'd use it, and specifically how to force traffic through inspection appliances, which is crucial for security and compliance. This isn't just theory. I'll show you real scenarios where UDR solves critical business problems, from securing multi-tier applications to meeting compliance requirements. What is UDR? Let me explain what UDR actually is. By default, Azure handles all your routing automatically. It's pretty smart about it. But sometimes you need more control. User-defined routes let you override Azure's system routes. You create a route table, define custom routes, and associate the table with subnets. It's like creating your own GPS directions that override the default ones. The key components are straightforward. You have route tables that contain routes, and these routes specify where traffic should go based on destination addresses. You then associate these tables with specific subnets. Think of it this way. Azure normally says, traffic to the network 10.1.0.0/16 goes directly there. But with UDR, you can say, actually, send it through my firewall first at 10.2.0.100. Azure's default routing. Before we dive into custom routes, let's understand what Azure does by default. This diagram shows the standard routing behavior in Azure. Azure automatically creates system routes for communication within your VNet, between VNets that are peered, and to the internet. These routes work for most basic scenarios. The default routes include local VNet communication, VNet peering routes, and a default route to the internet through Azure's Edge. This is efficient but doesn't give you control over traffic inspection or specialized routing requirements. Notice how traffic flows directly between subnets and straight out to the internet. There is no opportunity for inspection or filtering at the network level beyond what NSGs provide. Why use UDR? Now let's talk about why you'd want to override Azure's perfectly good default routing. There are several compelling reasons, and I've seen all of these in real customer environments. The biggest driver is usually security. You want all traffic to flow through a firewall or security appliance. Compliance requirements often mandate this kind of centralized inspection. Network performance is another factor. Maybe you want to route traffic through a WAN optimizer or ensure certain traffic takes a specific path for latency reasons. Cost optimization comes up too. You might want to route internet traffic through a specific egress point to take advantage of reserved capacity or peering agreements. I've also seen customers use UDR for troubleshooting. This could be temporarily routing traffic through a packet capture appliance to diagnose network issues. Core UDR components. Let's break down the key components you'll work with when implementing UDR. Understanding these building blocks is crucial for designing effective routing strategies. Route tables are containers for your custom routes. Think of them as rulebooks that you can apply to different subnets. You can have multiple route tables and reuse them across subnets with similar routing needs. Routes themselves define the routing logic. They specify destination address prefixes and where traffic should go. The next hop type determines how traffic gets forwarded. Subnet association is how you apply routing rules. Each subnet can have one route table, but each route table can be associated with multiple subnets. This gives you flexibility in your design. Next hop types. Understanding next hop types is critical because they determine exactly how your traffic gets forwarded. Each type has specific use cases and behaviors. Virtual appliance is probably what you'll use most for security scenarios. It sends traffic to a specific IP address, typically your firewall or N versus A. The appliance must have IP forwarding enabled. Virtual Network Gateway routes traffic through your VPN or ExpressRoute gateway. This is useful for hybrid connectivity scenarios. Internet forces traffic directly to the Internet, bypassing any default routes. None drops the traffic entirely. It's like a black hole route. VNet Local keeps traffic within the virtual network, which can override more specific routes in some scenarios. Creating your first route table. Let's walk through creating a route table step by step. I'll show you both the Azure Portal method and CLI commands, so you can use whichever you prefer. The process is straightforward. First, create the route table resource. Second, add routes to define your routing logic. Then, associate it with subnets where you want the custom routing to take effect. Notice how we're specifying the resource group and location. Route tables are regional resources, so they need to be in the same region as the VNets you'll use them with. The CLI commands shown here are what I use in automation scripts. The portal is great for learning and one-off configurations, but CLI is essential for repeatable deployments. Hub and spoke with inspection. Here is one of the most common UDR patterns I implement: the hub and spoke architecture with centralized traffic inspection. This is incredibly popular for enterprise customers. In this setup, all traffic between spokes must transit through the hub, where your security appliances live. UDR makes this possible by overriding the direct VNet peering routes. The key insight is that even though spoke A and spoke B are peered to the hub, we use UDR to force their inter-spoke traffic through the firewall instead of allowing direct communication. This pattern gives you complete visibility and control over east-west traffic, which is crucial for zero-trust architectures and compliance requirements like PCI DSS or SOX. Internet traffic inspection. Forcing internet traffic through inspection appliances is another critical use case. By default, Azure virtual machines can reach the internet directly, but you often want to inspect and filter this traffic. This diagram shows how we use UDR to redirect internet-bound traffic through a next-generation firewall. The firewall then applies policies before allowing traffic to reach the internet. The trick is using a default route 0.0.0.0/0 pointing to your firewall appliance. This overrides Azure's system route to the internet and ensures all outbound traffic gets inspected. I've implemented this pattern for customers who need to block certain websites, apply DLP policies, or simply log all internet access for security monitoring. Multi-tier application security. Let's look at how UDR secures multi-tier applications. This is a classic scenario where you have web, application, and database tiers that need controlled communication. Without UDR, these tiers could communicate directly if they're in the same VNet. But security best practices require inspection and filtering of inter-tier traffic. By implementing UDR, we force all traffic between tiers through security appliances that can apply application-specific policies, detect threats, and log all communications. This pattern is essential for applications handling sensitive data or operating in regulated industries. The security appliance can perform deep packet inspection and apply policies based on application context. UDR is crucial for hybrid cloud scenarios where you need specific routing between Azure and on-premises networks. Default routing doesn't always give you the control you need. In this example, we're forcing certain traffic destined for on-premises to go through a security appliance before reaching the VPN gateway. This ensures all hybrid traffic is inspected and logged. You might also use UDR to implement traffic engineering, routing different types of traffic through different connections based on performance or cost requirements. I've seen customers use this pattern to ensure that sensitive data always flows through a dedicated ExpressRoute connection while general traffic can use VPN tunnels. UDR implementation best practices. Let me share some hard-learned best practices from implementing UDR in production environments. These tips will save you from common pitfalls and design issues. First, always plan your IP addressing carefully. UDR works with destination prefixes, so overlapping or conflicting address spaces can cause routing issues that are difficult to troubleshoot. Document your routing design thoroughly. UDR can create complex traffic flows that are not immediately obvious. Future engineers, including yourself, will thank you for clear documentation. Test your routing thoroughly, especially failover scenarios. What happens if your security appliance goes down? Do you have backup routes or will traffic be blackholed? Monitor your routing performance. Adding hops through security appliances will increase latency. Make sure this is acceptable for your applications. Route priority and conflicts. Understanding route priority is crucial when you have multiple routes that could match the same traffic. Azure follows a specific order when determining which route to use. The most specific route wins. A /32 route will always be preferred over a /24 route. This is standard longest prefix match routing behavior. Among routes with the same prefix length, user-defined routes take priority over system routes. This is how UDR can override Azure's default behavior. If you have multiple UDR routes with the same specificity, Azure will choose based on route source priority. Understanding this hierarchy prevents unexpected routing behavior. I always recommend using route monitoring tools to verify that traffic is flowing as expected. Troubleshooting UDR issues. Let me show you the essential troubleshooting tools for UDR. These commands and techniques will help you diagnose routing issues quickly. The AZ Network NIC Show Effective Route Table command is your best friend. It shows exactly which routes are active for a specific virtual machine. This helps you understand why traffic is flowing in unexpected ways. Network Watcher's Next Hop feature lets you test routing decisions without actually sending traffic. You can verify that a specific source and destination combination will use the expected route. Don't forget about basic connectivity testing. Sometimes what looks like a routing issue is actually a security group rule or firewall policy blocking traffic. I always start troubleshooting with the effective routes, then use Next Hop to verify the routing decision, and finally test actual connectivity to confirm the full path is working. Performance considerations. Let's talk about the performance impact of UDR. Because every additional hop adds latency and potential bottlenecks to your network traffic. The most obvious impact is increased latency. Instead of direct communication, traffic now has to traverse your security appliances. This might add 1 to 5 milliseconds per hop, which can accumulate in chatty applications. Throughput can also be limited by your security appliances. A firewall that can only handle 1 gigabits per second will become a bottleneck even if your virtual machines could communicate at 10 gigabits per second directly. Consider the processing overhead of your security appliances. Deep packet inspection, threat detection, and logging all consume CPU and memory, which can impact performance under load. I always recommend performance testing your UDR implementation under realistic traffic loads before deploying to production. Security and compliance benefits. Now let's focus on why UDR is so valuable for security and compliance. These benefits often justify the complexity and performance overhead. Centralized traffic inspection is the big win. All network traffic flows through your security appliances where you can apply consistent policies, detect threats, and maintain audit logs. This centralization simplifies compliance reporting. Instead of trying to aggregate logs from dozens of systems, you have a single point where all traffic is inspected and logged. UDR enables micro-segmentation by controlling exactly how different parts of your application can communicate. This limits blast radius if one component is compromised. For compliance frameworks like PCI DSS, HIPAA, or SOX, UDR helps you demonstrate network controls and maintain the audit trails that auditors require. Let's be honest about the cost implications of UDR implementations. While UDR itself doesn't cost extra, the architecture patterns it enables do have cost impacts. Security appliances aren't free. Whether you're using Azure Firewall, third-party NVS, or deploying your own firewall virtual machines, there are licensing and compute costs. Increased data transfer is another factor. Traffic that used to flow directly now traverses additional hubs, which can increase your data transfer costs, especially for cross-region scenarios. However, UDR can also enable cost optimizations. You might route internet traffic through a specific egress point to take advantage of committed use discounts or peering arrangements. The key is to model your traffic patterns and understand the cost trade-offs before implementing complex UDR architecture. Automation and management. Let's talk about automating UDR management, because manually managing route tables across multiple environments isn't scalable or reliable. Azure Resource Manager templates are great for defining your UDR configuration as code. You can version control your routing configuration and deploy it consistently across environments. The Azure CLI commands I'm showing here can be scripted for automated deployments. I often use these in CI/CD pipelines to update routing configurations as part of application deployments. Consider using Azure Policy to enforce routing standards across your organization. You can require that certain subnets always have route tables or that specific routes are always present. Monitoring is crucial. Set up alerts for route table changes and monitor the health of your security appliances, since they're now critical path components. Advanced UDR patterns. Let me show you some advanced UDR patterns that solve specific architectural challenges. These are patterns I've developed working with enterprise customers on complex requirements. Conditional routing based on source location is powerful. You can route traffic differently depending on whether it originates from your corporate network, partner networks, or the public internet. Traffic engineering for performance optimization lets you route latency-sensitive traffic through high-speed paths while sending bulk traffic through cost-optimized routes. Disaster recovery routing can automatically reroute traffic through backup security appliances if your primary inspection infrastructure fails. These patterns require careful planning and testing, but they enable sophisticated network architectures that meet complex business requirements. Summary and next steps. Let's wrap up our comprehensive journey through Azure UDR. We've covered a lot of ground, from basic concepts to advanced implementation patterns. The key takeaway is that UDR gives you precise control over network traffic flow in Azure. Whether you're implementing security controls, optimizing performance, or meeting compliance requirements, UDR is an essential tool. Remember the core patterns we discussed: hub and spoke with inspection, internet traffic filtering, multi-tier application security, and hybrid connectivity. These solve the majority of real-world routing challenges. Your next steps should be to start small, implement UDR in a test environment, understand the traffic flows, and gradually expand to more complex scenarios. The investment in learning UDR will pay dividends in your Azure networking capabilities. Please consider subscribing to the channel. I would greatly appreciate it. Thank you for joining me on this deep dive into Azure UDR. I hope this gives you the confidence to implement sophisticated routing solutions in your own environments.